Hello guys, hope you guys are doing well. Welcome back to this class. Today's topic is linear algebra and this is this 12th session of Numpy. Numpy package contains linalg module that provides all the functionality required for linear algebra. Some of the important functions in this module are described on the screen. You can go through it. I'll zoom this one. All right, so we first one we have a dot. It is used to calculate the dot product of two arrays. And we have second v dot. It is used to calculate the dot product of two vectors. And the third one inner. It is used to calculate the inner product of two arrays. And the fourth one matmul. It is used to calculate the matrix multiplication of two arrays. And the fifth one det. It is used to calculate the determinant of a matrix. And the sixth one solve. It is used to solve the linear matrix equation. And the last one we have is in. It is used to calculate the multiplicative inverse of the matrix. Now we talk about dot function. This function is used to return the dot product of the two matrices. It is similar to the matrix multiplication. Let's consider this as an example. We'll go back to Jupyter Notebook and we'll see what we can do. Linear algebra. Sorry, I'll copy this and I'll open the right. This will be our heading for today, and I'll change it to 2, and I'll say okay and hit Shift Enter. Right. Now we'll import NumPy as NP. And we have a is equal to a array is np dot array, and we have we'll take it 100, 200, and we'll take it 21, comma 23, right? And we have another array of b array, and in this array we'll take it as 10 comma 20, and comma we'll take one more and we'll say 21 comma 12, right? Now we use the dot function. So we need here, we need to assign numpy dot dot. So I'll change this as a heading to 3. I'll be sharing these practical notes on my link, so you can download this practical code as well. All right, now dot is equal to np dot dot of a comma b. Now I'll print dot. Let's see. Oh, we have an error here. Let's see why we have an error. Module numpy has no attribute array. So we have a spelling mistake there. A-R-A-Y. A-R-R-A-Y. Let's execute. So we have the answer here is 5200 with something, right? Right, guys? Hope this is clear. And let's move on to v dot, next one. This function is used to calculate the dot product of two vectors. It can be defined as the sum of the product of corresponding elements of multi-dimensional arrays. Let's take a look at this an example. Numpy dot array. Let's go back to our Jupyter node and see numpy dot v dot, and here we have a heading, and let's import numpy as np, and a is equal to np dot array of, and we have 100 comma 200. What I do is I'll copy the a and b from the our previous example, feeling a bit lazy to type it. V dot is equal to np dot v dot a comma b, and print of v dot. Let's execute. What do we have here? We have this number here. Is it clear? All right, we'll move on to next one is numpy dot inner. This function returns the sum of product of inner elements of the one-dimensional array. For n-dimensional arrays, it returns the sum of the product of elements over the last axis. Remember that, over the last axis. Let's check this out in our example in Jupyter Notebook. Okay, let's say import numpy as np. A is equal to np dot array of 1 comma 2 comma 3 comma 4 comma 5 comma 6, and b equal to np dot array of, let's say I'll take 22 comma 22 comma 12 comma 2 comma 1 comma 2, 2. Right, so now inner is equal to np dot inner a comma b. Let's print this out. Inner, let's see what we have. 127. One plus two plus three plus one plus two plus three plus one five plus six plus 22 plus 22 plus 12 plus two plus one plus two. Okay. Right. Let's move on to dot. We have done inner, and let's say we are at determinant. What is a determinant? Um, are we missing something here? Inner determinant. That the determinant of the matrix can be calculated using the diagonal elements. The determinant of the 2 by 2 matrix will be, for example, and write it down here. If we have A and B, C and D, consider this. And this This can be calculated as AD minus BC. That will be diagonal determinant, right? The then function is used to calculate the determinant of the matrix. Let's take a look at this. Okay, let's import numpy as np. A is equal to np dot array of 1 comma 2 comma 3 comma 4, right? We'll take this as an array and print np dot lin alg dot det of a. Let's execute this code and see what we have. We have minus 2. How? So in our example, what it says A, B, C, D. So this is A and B, C, D. So AD minus BC. A, B, C, D. AD minus BC. Right? So A, B, C, D. AD is 4 minus, sorry, CD is 6 minus, sorry, 4 minus 6 is minus 2, right? So we have A as 1 and B has 2 and C has 3 and D has 4. Let's consider this as AD. What is our A is 1 into D is 4 and we have minus, B is 2 and we have C is 3. So we have 4 minus 6, that will be minus 2. Is that clear? This is the answer what we have got here. Simple as that. Any doubts? Right. Let's move to second one. Numpy dot alg solve. This function is used to solve a quadratic equation where values can be given in the form of the matrix. Linear equations are, so you can see it on the screen, linear equation 3x plus 2y plus z is equal to 10, x plus y plus z is equal to 5, can be represented by using three matrices as 3, 2, 1, 1, 1, 1, or x, y, z, and 10y. The two matrices can be passed into a numpy.solve function as this. Take a look at this with an example. So you'll understand this function, right? Solve function 3. Import numpy as np, and I'll say a as np dot array of 1 comma 2 comma 3 comma 4. B is equal to np dot array of 1 comma 1 comma 2 comma and same as 3 comma 4, right? Let's see, print np dot lin al solve a comma b. Let's execute this. What we have here is, this is our output. Okay, let's move to in function. This function is used to calculate the multiplicative inverse of the input matrix. Multiplicative inverse of the matrix. This function is used to calculate the multiplicative inverse of the input matrix. Right. Let's try this in our example. Let's import numpy as np a array np dot array. We'll take it 1 comma 2 comma 3 comma 4, right, and print original array. You can go it this way as well, of a print of slash n is nothing but a new line, and b is equal to np dot lin alg dot inv of a print inverse of colon slash colon of b. Right, let's execute this code. And numpy where import impo rt, execute. End of file, we have an error inverse. There is the inverse of b. Here I might have done something wrong here. That's the reason I'm getting this print slash n. Here it is. So we original array is 1 2 3 4. We have the original array and we have an error for the name n is not defined. Where is n? This is not n. This is np. So we have the original is 1 2 3 4. The inverse is minus 2 1 1.5 0.5. This is the inverse. Alright guys. Alright, this is the end of this today's session. Hope you guys enjoy the NumPy linear algebra session. If you have any doubts, feel free to contact me and spend some time practicing on that. Try to understand the logics. So this might help you out. All right, all the best, guys. I'll join you in next session. Till then, take care. Bye bye.